Alright, so this is section 9.2, Pythagorean theorem. This is going to be into two parts. This first video is going to be part 1, which is about the Pythagorean inequalities. And so I use these inequalities to determine whether a triangle is right, obtuse, or acute, depending on if c squared is equal and it's right. If a squared plus b squared is less than c squared, it's obtuse. And if a squared plus b squared is greater than c squared, then it's acute. And so I just have kind of examples of what this is here. To be able to use this, you have to know what the hypotenuse is. Hypotenuse is just the longest side of my triangle. So if I give you a picture, you just look for the longest side. That's your hypotenuse. If I give you 3 measurements, which is what I'm giving you on these examples, then c would have to be the largest number. So that's the first thing you want to determine in example 1. I have to determine which one's the c value. So my largest number is 20, therefore c would be the hypotenuse. 20 would be the hypotenuse. So I'm going to write it right here. C is always the largest number. So once you determine that, then A and B doesn't matter. I can make A be 13 or I could make A be 9. It doesn't matter. The only one that matters is C. So once I label all my letters, I'm going to plug it in to my formula, which is a squared plus b squared equals c squared. And so I'm just replacing my letters with the numbers that I have. So my A value is 13. My B value is 9. And then the C value is 20. So I'm going to evaluate first the left side and then the right side. I'm going to put a question mark right there because I don't know if they're equal. That's what I'm trying to determine. So 13 squared, that's 13 times 13, that's 169. 9 squared, that's 9 times 9, that's 81. And so now it's a plus sign, so I'm just going to add those two. 169 plus 81, that gives me 250. And so now I'm going to do the right side. So on the right side, I just have 20 squared. So 20 times 20, that's 400. And so 250 is actually less than 400. So because it is less than 400, I'm going to classify this as obtuse. So this is going to be an obtuse triangle. So I have 2 more examples. Examples 2 and 3 are a little bit different just because now I have a side that has a radical, and so now I have to remember everything that we learned from section 9.1. So first thing I want to do is I want to determine which of these 3 numbers is my c value. 3 square root of 5, I have to change to a decimal so I can see if it's greater or less than 6. So just type that in your calculators. I'm going to type 3 square root of 5. Enter. That's about 6.7. So this is about 6.7. 6.7 is greater than 6, so that means this number has to be my c value. So I'm going to make this one is A, this one is B, this one's going to have to be C. Once I determine that that's C, I'm going to ignore that decimal. I don't need it because I need to plug in the radical. I need exact numbers. So I'm going to plug in the radical into my formula. So here's my formula. A squared plus b squared equals c squared. And I'm just replacing my letters with numbers. So A is 3. B is 6. And then the c, it's the 3 square root of 5. So I'm going to take all that, I'm going to put it in parentheses, and then square. Okay, so same as the previous example, I'm evaluating each term. First, I'm going to do the left side. So on the left side, I have 3 squared, that's 3 times 3. That's 9. 6 squared, that's 6 times 6. That's 36. And so now I just add those two. 9 plus 36, it gives me 45. So again, I'm trying to determine whether they're equal or not. Okay, so this is what we were doing during the last section. 3 squared of 5 squared is that I'm multiplying this quantity twice. So I'm going to expand that. I'm just going to write it twice so I can show you what work I'm doing. So for this side, the 3 times the 3, that's going to give me 9. Then I have to multiply the square roots together, the radicals. So the square root of 5 times the square root of 5, you remember that it's just 5. The square roots cancel, so it's just 5. And so this is a times sign, that's not a point, that's a times. So 9 times 5, that's 45. So on this problem, I end up with both numbers equal. So anytime that both numbers are equal, that is a right triangle. So that one's right. And then so for the last one more example. Again, I have a square root. And so I'm going to check that just to make sure that that's not the biggest number. So I'm going to take 2 square root of 3. That gives me about 3.5 if I'm rounding. So this one gives me about 3.5. Therefore, it is not the biggest number. That means 6 has to be C because that's the biggest number. And then this one's A and this one's B. So again, plug in. A is 5. B is 2 square root of 3. And C is 6. Okay, so for this one, I'm going to skip this process. If you know how to do it mentally, you don't have to show all this. I'm just going to show you how you would do it mentally, if that's the way you prefer. So here I'm going to do 5 squared. One's easy, that one's 25. So if you want to do this one mentally, you would do 2 squared. So that's 2 times 2. That would be 4. And then times the number inside, times 3. So 4 times 3 is 12. So I'm going to write 12. And then here, 6 squared, that's 36. So now I'm going to check if they're equal or not. 25 plus 12, that's 37. On the right side, I have 36. So 37 is greater than 36. So this time my triangle would be acute.